Hello, my dear students. This is your professor, Dr. Syed. You are welcome to the online digital learning program. Today I am going to teach you about the methods of melting on the different types of furnaces. What's a furnace? A furnace is a heating media or a device. It's used for heating and melting purposes. For providing heat to chemical reactions, for the processes like cracking, the furnace may be heated by fuel, as in many other furnaces, coke is used as a fuel. Some of the furnaces are operated by electrical energy. That's why they are called electric arc furnaces. Furnaces are used for casting processes. There are many types of furnaces which are used in the foundries. One is cupola furnace, another is direct fuel fired furnace, another one is crucible furnace, another one is electric arc furnace, and another one is induction furnace. This is the model of crucible furnace. You can see here from one side gas and air are entering inside the furnace. We will see the more details in the next slide. These are all the electric furnaces. The left side what you are seeing here is induction furnace and the right side is an electric furnace. Coppola furnace. It's just like a vertical cylinder furnace equipped with tapping spout near base. It's used only for cast irons. Although other furnaces are also used, the largest tonnage of cast iron is melted in cupolas only. The charge. The charge consisting of iron, coke, flux, and possible alloying elements. All these things has been loaded through a charging door located less than halfway up height of the cupola. This is the cupola furnace. Now you can see the different parts of the cupola furnace. Cupola furnace left side we can see there is a shell. The shell is the outside part of the cupola. The left side there is charging door and there is charging floor and there is wind box, then slag spout, then finally at the bottom there is bottom door. This is a dropped position, that's open position. The right side, the top part is spark arrestor. Then stack. Stack means it says about the length of the cupola furnace. The stacks are different lengths for different capacities of the furnaces. After that, there is preheating zone. Under that, there is melting zone. Again under that, superheating zone. Then again under that, well, that is bot. Again, after that, the tapping spout, that is, the melted material will be collected from this place. This is a cupola furnace, but this is a very heavy furnace. Where the heavy industries are using these types of cupola furnaces. Direct fuel fired furnaces. Small open hearth furnace in which charge is heated by natural gas fuel burners. These burners are located on the side of the furnace. The roof of the furnace will assist the heating action by reflecting the flame down against the charge. The bottom of hearth is a tap hole to release molten metal, generally used for non-ferrous metals such as copper base, alloys and aluminium. Crucible furnaces. The metal is melted without direct contact with burning fuel mixtures. So there won't be any direct contact with the burning fuel mixtures in crucible furnaces. Sometimes these furnaces are called indirect fuel fired furnaces. The container, which we call as crucible, is made up of refractory material or high temperature steel alloys. It is used for non-ferrous metals such as bronze, brass, and alloys of zinc and aluminium. There are three types of crucible furnaces. One is lift out type, the second one is stationary, third one is tilting crucible furnace. Now you are seeing a very heavy crucible furnace which is using in the industries. Heavy industries, they use this much of heavy crucible furnaces. These are the different types of crucible furnaces. Here we have shown three types of furnaces. The three types of crucible furnaces are, from the left side, lift out crucible furnace. In the middle one is stationary pot furnace, and the right side one is tilting pot furnace. This is an electric arc furnace. The charge is melted by heat generated from an electric arc. The source of heating is electricity. Here, electric arc furnaces are designed with high melting capacity. Here, a high power electric consumption is used. These furnaces are used primarily for melting the steels. Induction furnaces. In these induction furnaces, the alternative current is passed through the coils to develop magnetic field in the metal. The induced current causes rapid heating and melting. Electromagnetic force field also causes mixing action in liquid metal. Because the metal doesn't contact heating elements, we can have a good environment that can be closely controlled to produce molten metals of high quality and purity. We can make melting the steels, melting the cast irons, melting the aluminum alloys that are commonly applicable in the foundry work.